Welcome to our AI for Everyone instructional video series. This instructional video series is developed by the American Institute for Professional Training and Development, a nonprofit organization. This educational video series is designed to provide an opportunity to learn about AI and explore how to benefit from this remarkable technology. The entire series is available to view at no charge. My name is Sandy, and I will be the AI avatar guiding you throughout this presentation. ChatGPT, Claude, and Gemini, they all come from different companies with different personalities and price tags. But underneath, they are all nearly built on the same architecture. It's called the transformer architecture, and it's arguably the single most important idea in modern AI. In this presentation, we'll try to take a look at the transformer architecture in a simplified way. No complicated math, no algorithms, just a look at the basic core idea behind them. Here's something that often surprises some people. ChatGPT, Claude, Gemini, and Llama may look wildly different on the outside, but on the inside, there is one design behind them all. They're basically variations on the same transformer blueprint. They may have different training data, different sizes, and different tuning, but are basically built on the same fundamental design. So once you understand the idea of the transformer, you understand the engine inside almost every chatbot, coding assistant, and AI writing tool out there. The transformer is one idea with enormous reach. To appreciate why it mattered, picture how AI read text before. Older models processed language the way you'd read a ticker tape, one word at a time, in strict order. That created two headaches. They were slow, because each word had to wait for the one before it to finish. And they were forgetful. By the time the model reached the end of a long sentence, the beginning had started to blur. Context kept slipping away. It's like trying to understand a paragraph by reading it through a tiny moving slot. One word visible at a time, you will quickly lose the thread. A breakthrough came in the year 2017. A landmark research paper proposed something radical. Stop reading word by word. Instead, hand the model the whole sentence and let it look at every word simultaneously, deciding on the fly which words relate to which. That meant no more waiting, and no more forgetting the start. That mechanism, the ability to weigh how much each word should pay attention to every other word, is literally called attention, and it's the beating heart of the transformer. Let's take a closer look at the idea of attention. Words that look at other words in the same sentence. As the model considers each word, it quietly asks a question. Which of the other words around me give this word its meaning? It then assigns more weight to the ones that matter and less to the ones that don't. This is called self-attention, because the words in a sentence are attending to each other. And crucially, it happens for every word, across many stacked layers, all at the same time. Think of it this way, it's like a group conversation where, before speaking, everyone instantly glances at everyone else to catch the context. That glance would be described as attention. Here's a classic example of attention in action. Let's look at the sentence. The cat drank the milk because it was hungry. Now let's think together. Who or what does the word it refer to? You know instantly. It's the cat and not the milk. The model solves this the same way, through attention. When it processes the word it, the model sends strong attention back to cat, even though several words sit between them. No rereading, no guessing in the dark. Every word is directly connected to every other word all at once. That long-range understanding is what older models struggled with. So what actually happens inside a transformer? 4 basic moves at a high level. 1. Your text is split into tokens, the little chunks we covered earlier. 2. Each token is turned into a list of numbers called an embedding, so the model can do math on meaning. 3. Those numbers pass through layer after layer of attention, refining which words matter to which. 4. The model predicts the most likely next token. Then it repeats that last step, token by token, building your answer one piece at a time. That's the transformer in action. Now the payoff that changed everything. Why the transformer took over. Because the transformer looks at all words at once, the heavy computation can run in parallel, thousands of calculations side by side, instead of a slow single-file line. That made it possible to train these models on staggering amounts of data using modern hardware. And it unlocked a simple, powerful pattern. More data plus bigger models tended to produce better results. Parallelism is the quiet reason transformers could scale in ways nothing before them was able to do. You may already know this. The letters GPT in the name ChatGPT are an acronym. The letter G stands for generative, because the model creates new text. The letter P is for pre-trained, because it learned from vast data ahead of time. And the letter T is for transformer, which is the architecture we've been describing in this presentation. The letter T that you say every time you mention ChatGPT is referring to the transformer. Many people don't realize that the term transformer is actually mentioned in the name ChatGPT. The power of transformers extends far beyond chat. The same transformer architecture is also behind the ability to translate between different languages. Transformers are also used for code generation, bug fixing, and in an intelligent search that understands what you actually mean. Not just the keywords that you typed. Is also using transformers. The transformer blueprint is a general-purpose technology, which is exactly why it has spread to nearly every corner of AI. Now for our 3 takeaways. Number 1. Attention is the core idea that describes how models weigh words and which other words matter most in a given sentence. Number 2. AI models process everything in parallel, which makes it fast and scalable. Number 3. The transformer architecture is the underlying technology behind nearly every modern AI. Transformer power is at the core of most of today's AI models. Thank you for joining me in this presentation. I invite you to join me again in our next video,
where we'll discuss
what does training data mean and why it matters,